Hi there, thanks for joining me. Today I'll be showing you how to conduct a logistic regression using SPSS 15. And even though I'll be using SPSS version 15, this particular syntax has been pretty well established as a stats routine in SPSS for some time. So this should be pretty stable for later versions as well. And just really briefly to go through some of the assumptions of logistic regression, all of the typical modeling assumptions that you would really make of any kind of general linear model or any other generalized linear model pretty much apply to this particular situation. And there are a few logistic specific assumptions. Specifically, you want to be sure you have a binary outcome variable, unless of course you're doing a binomial model, which I won't be talking about today, and that's logistic regression is a specific case of the larger binomial family of generalized linear models. You also don't really need to have linearity as you would in ordinary least squares regression or multiple regression. You don't need to have the linearity between the predictors and the outcome variable or the dependent variable. Instead, what you need to have is linearity in the logit, which basically means the actual linear regression equation that sits within the larger logistic regression equation, and it will be linked to a larger model. So you need to have linearity in that. You also need to have a lack of perfect separation between your two groups that make up the binary outcome variable. So that's also really important. You can't have predictors that completely separate those two options. So those are the main assumptions, just touching on them briefly, and I'll take you to our data set. Just to give you a quick rundown on what these data are, I generated them using the M+ program and then shaped them slightly for the purposes of this particular demonstration. And I'm going to be demonstrating to you a logistic model where I'm predicting this variable right here, presentation for substance abuse treatment, so whether or not participants attended their assigned substance abuse treatment session. And I will have the predictors, these three predictors in the model, dummy-coded gender, so coded as, let's go in here and check, 0 for women and 1 for men. I also have a centered motivation for treatment variable. And just like with OLS regression, you should center all of your continuous variables. I also have an interaction of the dummy-coded gender and center motivation variable, and I'll be putting that into a full model and comparing that to the reduced model with just these two variables in it. So we also have 500 cases in this particular data set. So that should be adequate for this size of a model. So in order to pull up the logistic regression routine in SPSS, you can generally go under the Analyze tab, and there's a new set of routines under generalized linear models, and those are found here under generalized linear models. Those also allow for logistic regression to be performed amongst many other different families of the generalized linear models. The more established logistic regression routine is under regression, and you can click on binary logistic. Multinomial logistic is for outcome variables with more than 2 potential outcomes. So we'll stick with binary for now. I'll go ahead and reset that. The dependent variable, we just need to click on that and move it over with this little arrow here. That'll be our outcome variable. And then the covariates go into these different blocks. They have them set up. So that's the way you can organize having reduced models and comparing them to fuller models. So we'll go ahead and put the dummy-coded gender variable and the center motivation main effects in the first block. And on the second block, we can go ahead and add the interaction, and that way we'll be able to compare the predictive ability of the interaction above and beyond the contributions of the main effects. So now we have these two blocks. You can click amongst them by just clicking previous and next to view those. Our method is going to be the enter method, and that's one of many choices here. The others are typically used when doing different variants of stepwise regression. And unless you have a really large sample set and you're willing to do cross-validation, I would definitely recommend the enter method. The other ones are going to provide less stable regression coefficients. So typically, unless you're doing a lot of cross-validation, the enter method is a good default. Then you can specify using this categorical tab right here any categorical variables that you have, that is dichotomous variables or any kind of categories. And because demi-coded gender is definitely a categorical covariate, we'll put that in here. And because we have our reference group being women, which is coded as 0, we're going to go ahead and choose the first reference category to serve as our reference group, because 0 obviously comes before 1. So we need to go ahead and change that here. And if you want to do other kinds of contrasts, you have a list here. They're pretty similar to the same kinds of contrasts that you can choose for OLS regression as well. So we can go ahead and hit continue once we've specified that. And the next tab we can look at here is save. I do like to save certain kinds of values just for later use. What you can do is you can save different probabilities for the different participants that you have in your model. You can also save their group membership and compare that, see how well your model classified your particular participants into their groups. And you can also look here at any undue influence certain cases might have on your model, particularly in case you have multicollinearity, or there's a particularly influential outlier. This will help you kind of decide. For example, this one here shows you how much the inclusion of certain cases will change your beta weights, or your, in this case, your coefficient weights. You can also save your residuals, which I do recommend saving the standardized residuals definitely, so you can check and see if there are any outliers in your model that might be pulling your model off. And you can also look at options here. I typically choose more rather than less because it's always good to get multiple views on the goodness of fit of your model, and there are some good routines here. Mainstay is the Hosmer-Lemeshow goodness of fit, and I'll explain that when we get to the output. You can choose classification plots, which will show how well your model classified your people, but more in the graphic form. And a case-size listing of residuals, so you can see a quick and dirty chart of your of the largest residual outliers in your data set. Another really important one to click is to be sure to ask for the confidence intervals for your exponentiated coefficients. That's the EXPB, is the exponentiated unstandardized coefficient, and that will end up being your odds ratio. So that's always good. A lot of journals want that reported. Down here, these defaults are typically good. A classification cutoff just indicates at what point the probabilities will be counted, either going towards a 1 as an outcome or a 0. So 0.5 is for this particular purpose, okay? And maximum iterations at 20 is typically going to be sufficient for a model of this size to converge. So we can continue there. And at this point, we can go ahead and paste our syntax into our syntax window. And you can run that by highlighting this and clicking this arrow here. And that's it for the syntax portion and the introduction to this model. In the next piece, I will be explaining the output. So thanks for joining me. See you soon.